Hey there, how's it going? Well, in today's class, we're going to talk about combining series and parallel circuits. In the other class, we only had circuits where you had resistors in series, and we had other parallel circuits where there were only resistors in parallel. But now we're going to have a combination of the two. How is that going to look like? Well, it's going to be like this. They're going to be asking us to simplify the circuit that you see right here. And the idea, guys, is that you got to identify which things are in series and which are in parallel. So the big idea is going to be this. When you have a resistance and there's another resistance, there's going to be something in the middle. That thing is going to be the connection when you have those two resistors. When there's only just one path from one resistor to the other, that's going to be series connection. But if you have something like this, one resistor and another resistor, well, now that's going to be in parallel because the whole idea is that they have one connection here and you have another connection over here. You get one connection, two connections. There are two connections now, so that makes it a parallel circuit. But when you have just one connection, it's in series. But watch out if you have one resistor and another resistor. Okay, right now it is in series. But if it puts something else right there, not anymore, that's not in series. So what do you do then? Well, you got to simplify something over here to make it become either series or in parallel. Because right now, this is not series and it's not even also parallel. It's neither. So let's start with this problem over here. Alrighty, so let's see. This 5 ohms and this 12 ohms. You can say, teacher, this right here, that thing, that's in series, teacher. But you know what? It's not because there's something in the middle. That's what I'm telling you about over here. So we can't start to simplify the 12 and the 5 to add them and then to say, oh, teacher, we just gotta add. That's it. No, 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 nope. We can't do that. And also this 3 and this 12, it's not in series. Well, what do we do? Because why is it not in series, the 3 and the 12? Because there's again something in between. There's something in between coming between those two resistors. So we can't simplify the 3 and the 12. But how about this 7 and this 5? So this 7 and this 5, as you can see, there's only one connection between them, and that's what's important. That's it. So that makes it a series connection. This thing here, the 5 and the 7, they are series connections. So the 5 and the 7, you can add them and it becomes 12. So that's going to be this equivalent circuit. So just this little resistor is equivalent to this. So what do I have to do in my procedure? I have to simplify this circuit step by step until I reach just my one equivalent resistor. So that's the whole point of this, to change this thing into one small resistor. Alrighty guys, that's the big idea. And I just started by simplifying these two resistors. So the 7 and the 5, you add them and it gives us 12. And then what's going to be next? The 12 and the 12, you gotta add them together. What, do I add them together or what should I do? This 12 and this 12, what are they? You see here, the 12 and the 12, they have this connection and they have this other connection. That makes it a parallel circuit. So the 12 and the 12, I gotta do the reciprocal. So it's gonna be 1 over 12 plus 1 over 1 over 12. And of course, that's what I'm going to show you in the next one. So, what's going on, guys? Okay, so 1 over 12, it's going to be the same as doing 12 times 12 over 12 plus 12. And Okay, when you multiply 12 times 12 is 144. Divide by 24. If you do the whole thing, it's going to be 6, guys. Because also the other trick that I had showed you in the other one, in the other video, maybe you catched it, maybe you didn't. But the idea, guys, is that if you have two circuits, two resistors that are in parallel and they have the same resistance, it's the result is going to be the half. It's going to be the half of the two numbers. So another key idea is that when you have resistors that are in series, you gotta add them. They're gonna become bigger. But when you put resistors in parallel, they're gonna become smaller. That's something also very important, guys. Okay, I don't know if you've noticed that in the previous video, but that's what happens. Okay, so we get so this 12, and this 12 that are parallel are gonna become just this 6. Now the 5 and the 6, you see what happens between those two guys? There's only one connection, so you can add them. And also this 6 and this 3, also just one connection. So these guys, the 3 resistors, are in parallel, and this is going to be the equivalent resistor that I'm looking for, and I'm done. That's it. That's it for this problem, guys. We're set. We got the equivalent resistor. We're done. Okay, what about this other one? Alright, let's check it out. We have a 40 and a 30 and a 28 over here. And it seems that it's pretty evident that the 40 and the 30 are in parallel. So what do? 40 and the 30 parallel. I gotta do this procedure. Now you may be asking yourself, 28 and 40, that's in series. I could do that. No, guys, there's something in between. It's not going to be in series. As I place here, in series there's just one connection, and when it's in parallel there are going to be two connections. So in parallel, what you have to do is going to be 1 over 1 over 40 plus 1 over 30. It's going to be the sum of the reciprocals, or you can also do this in the calculator very quickly as 40 and then there's a key that is x to the power of -1 plus 30 x to the power of -1. You gotta do that, and then you gotta do also for the whole result x to the power of -1, and that's gonna be the result that we get also over here, or you can do it manually as I placed right there. And alrighty, let's do this other one also. So we get the result of this 40 and this 30, and it gave us 17.14, which is this resistor. What's going to be next? This 28 and this 17.14. As you can see, they are in series. So what do I do now? I just got to add them, and it's going to be 45.14. You are done. That's it. This is the equivalent resistor for this circuit. Let's do one more. Now this one, what's going on here? What this is saying to me, it's that all of the resistors here have the same amount of resistance. It's going to be 6 ohms for all of them. How do I proceed to solve? Well, the 6, this one and this one, this resistance and this resistance, you may be like, teacher, that's in series, but it's not. I would say it's not, because there's something else over here. You see this thing? It's in between these two resistors, so that's not going to be a series connection. What about these guys? What about all of this and all of this? They are in parallel also with this one, but first I gotta simplify this circuit inside of it. Okay, so I gotta do this first. It's pretty easy because, as you can see, there's only one connection that makes it in series, so we gotta add the 6 with the 6, and it gave us 12. And then this 6 and this 6, I gotta put them together, and it's gonna be also 12. Okay, so these two guys are in series as well as these two guys, and I can simplify them and I get the 12, and then this 6 plus the 6, it's gonna be 12 as well. And then this 6 over here and these other 12s, now I can see pretty clearly that they are in parallel, because as you can see, this is connected with this guy, and it's also connected on the other side with this guy, and they have two connections. This terminal is connected to the terminal of this other resistor, and that makes it parallel. And of course this one over here is going to be as well connected, and now they are going to be in parallel. So I gotta do the resistors that I have here. It's going to be 1 over 6 plus 1 over 12 plus 1 over 12, and all of that I gotta take the reciprocal of that. So it's going to be 1 over the reciprocals of all of these. You do this operation properly and it's going to give you a 3. That's a check mark. It's set. We got the answer for this one. So all of these guys, they were in parallel, and it turned into this one over here, this 3 ohm resistance. And then 3 ohms and the 6 ohms, you got to put them together. Now they are going to be in series, of course, so you can put them together just by addition. 3 plus 6, that's 9. And you're done, guys. Well, that's it, guys. I don't know if you have questions about this. Check it out. Check out the videos again if you have more questions. If you have more questions, actual questions about the content here or the exercises, you know where to find me. Alrighty? Well, you have a great day.